we're going to do today is just this whole balancing of chemical equations. Let's just do a quick reminder of why we have to balance chemical equations. There's a law, so balancing chemical equations, and there's a law that goes with that kind of explains why it is that we need to balance chemical equations. And who remembers what that law is? Right, perfect. Okay, so we've got the law of conservation of mass, which basically says we can't create or destroy atoms. And yet a lot of the times when we write these chemical equations, we write them in an unbalanced way, which makes it appear like mass is being created or mass is being destroyed, and we can't do that. So if we take a look on page 79 of your workbook, we'll take a look at G, and just kind of see how to go about that process of balancing again. So if you look at G, the unbalanced chemical equation right now says, what's the name of that compound? Borium. Now, is borium a metal or a non-metal? Non-metal. Do we know if it's ionic or molecular? Okay, so borium mononitride plus Cl2, and remember chlorine gas, when chlorine's by itself, it's diatomic. It's a diatomic element, so it's going to be written in a pair, and that produces borium chloride, trichloride, and nitrogen gas, which is also a diatomic element. So if you take a look there, here's what you would probably be thinking. You'd be thinking, okay, so I've got one boron there, I've got a nitrogen atom there, and this one happens to have 3, so I'll need 3 colors. I'll use black here. We've got 2 chlorine atoms there, and then when you get over to this side, we've got 1 boron, we've got 2 chlorines, 3 chlorines, sorry, 1, 2, 3 chlorines, and we've got 2 nitrogens, and you start to take a look at all of the atoms on the reactant side compared to all of the atoms on the product side, and our conclusion would be we have gained mass. Because here's 4 total atoms over here on this side, and there's 5 total atoms on that side. Looks like we've gained mass. Not only that, pardon me? Oh, sorry, 6 on the right. So not only that, we have different atoms have different masses, and so you might argue, well, not even if they were the same, but they were of different makeup, if they were different elements, the mass could change. So we seem to have some sort of an issue here. So probably the easiest way to take a look at how to balance this is to make yourself a chart, and your chart would go something like this. You would go and compare your reactants to your products. So we'll put an R and a P for that. And on this side, you're going to list the different elements that are present. So we have boron present, we have nitrogen present, and we have chlorine present. And let's get some numbers down. So how many boron atoms are we starting with on the reactant side? Well, we're starting with 1. We've got 1 nitrogen. We have 2 chlorines. On the product side, we have 1 boron. We have 3 chlorines, and we have 2 nitrogens. And so now you can kind of have a starting place. And all we need to do now is get the number of atoms of each kind the same on the reactant side as on the product side. And then when we've got that, it'll be balanced. So it doesn't matter where we start. We start with the boron, we can say we've got 1 of each, so that seems to be balanced right now. So let's go to the nitrogens. And here's kind of the way I would go about with the mindset. I would just say to myself all the time, I would say, I need to get 2 nitrogens on the reactant side. How do I do that? And what I would do then is put a large number 2, a coefficient number 2, in front of that compound Bn, because what that means is that everything behind it gets doubled. So 2, we've had 1 nitrogen there, 1 times 2 is 2. So I've got my 2 nitrogens, but then I have to ask myself, what else does the 2 do? And it also bumps up my borons to 2. So then go back to your chart and change that to a 2 as well. So I solved my nitrogen problem, but I created a boron problem. So maybe I want to keep track of that. Maybe I'll just get my dots all set up here so we can kind of keep track. So that's what I've done so far. Okay, now I'm going to go to my nitrogen or boron side on my product side, and I'm going to say, okay, I need to get to 2 boron atoms on my product side. How do I do that? By putting a coefficient 2 in front, but then I have to look at what else that does. And what it does is it takes my 3 chlorine atoms and multiplies those by 2 as well. So all of a sudden I'm now sitting at 6 chlorine atoms on my product side. So I can kind of put those in. So now I've got borons, but my chlorines are all the way up to 6. So I got 3, 4, 5, 6. So borons are balanced now, nitrogens are balanced now, but not my chlorines. So now I go back to my reactant side and I say, I need to get to 6 atoms of chlorine on my reactant side. How do I do that? By putting a 3 in front there, and that'll get me my 6. The 3 doesn't affect anything else in that compound because there isn't anything else. So I now have 6. And then you can keep track of what's happened with these dots. So now I have 2 borons, 2 borons. I have 2 nitrogens, 2 nitrogens. I have 6 chlorines. I have 6 chlorines. It is now balanced. So here you can see the answers to the letters A through I, and you can check your answers in your book, page 79, to what is on the screen. Okay, so here we have letter J on page 79, and for the first time we're dealing with compounds that contain polyatomic ions. And again, you're going to have to learn how to balance these. So there's a little, it's not tremendously more difficult than what you've been doing, but there's a little trick that you can do. But let me first of all show you how, without this knowledge that I'm about to show you, you would start things. Here's what most of you would probably have done. You would have gone, okay, reactants, products, and then you start to, okay, so I've got a nitrogen, you say. I've got hydrogen showing up. I have phosphorus showing up. I have oxygen showing up. And you would have probably written all of those just like we've been doing. Calcium, you would have said, and bromine. And then you would have written down all of these atoms that you have of each, and then you would have tried to play this balancing game with, in this case, 6 different elements. That's going to be really hard to do. I'm not saying it would be impossible, but it's going to be really hard to do. So instead of doing that, what you're going to do with polyatomics is you're going to try and keep groups of atoms together if they show up on both sides. And that's really important. They have to show up on both sides in order for them to be kept together. So if you take a look here, we have an NH4 group that's showing up on both sides. That means that instead of balancing nitrogen and hydrogen separately, we're going to balance them together as a group. And you see, you also have phosphorus showing up on one side and the other. So we can keep that together as a group. And then the calcium will work out together in the bromine. So when you make your chart for this, it's going to look a little simpler if we say we're going to balance NH4 as a group. We're going to balance PO4 as a group. We're going to balance calcium, and we're going to balance bromine. And that just gives us a little bit better, a little simpler way of doing that. Now you handle it exactly the same as you always have. So you say to yourself, how many NH4 groups do I have? Well, I have 3 of them. That's what that little 3 means. So I have 3 NH4 groups. How many PO4 groups do I have? Just 1. How many calciums do I have? Just 1. How many bromines do I have? Just 2. And you've got to make sure your chart is right to start, or it'll never work. Okay, calciums here. I have 3 calciums on my product side. I have 2 PO4 groups. I have 1 NH4 group, and I have 1 bromine group. So there's my beginning table for that. And now it's just like we were doing before. So that, again, just kind of to follow things through, you would say, okay, I'm going to start with my NH4 group. On my product side, I need to get 3 NH4 groups. How do I do that? By putting a 3 in front of that. But then I have to look at what else the 3 does. So here, this 3 makes the NH4 groups go up by 3, but it also makes my bromine groups go up by 3. So then I have to go to my chart and I need to say, okay, that's how many I have now. Then I might go to my PO4 groups, my phosphate groups, and I say, okay, I need to get to 2 phosphate groups on my reactant side. How do I do that? Now look where I put the 2. I put the 2 right here. I can't write the 2 in that spot there because this is a compound. And so I can't split up my compound into 2 smaller little sections by putting the 2. So I have to put the 2 here so that 2 gave me 2 phosphate groups. But look what it did to my ammonium groups. Okay, I had 3 of them. Now I've doubled that. So now I have 6 of those groups. And then you kind of go, oh, I just finished balancing my ammonium group, so now they're out of balance again. Well, that's part of the game. So now I can go back to my ammonium groups, and I could say, okay, I need to get to 6 ammonium groups on my product side. How do I do that? I need to turn that into a 6 there. Okay. What does that do to my bromine groups? So, well, that also moves them up to 6. Okay, so my 6 bromines now. Okay, I'm almost there. It looks like my ammonium groups are balanced, my phosphate groups are balanced, my bromine groups are balanced, just the calciums yet. So I say, okay, I need to get to 3 calciums there. So I put a 3 there. How do I do that? Well, I'll be by putting a 3 there. Oh, sorry, my bromine groups weren't balanced. I think I just mentioned they were. But now they are, because I had 3, now I have 3 calciums and I have 6 bromines, and it's balanced. So by keeping your groups together, you're able to do a much better job, a much more efficient job of balancing things.